Well, today is Friday, November 20th, 2020, or 11/20/2020. This is our first ever podcast, episode 1, volume 1. I'm Tricia Cease, president of the Virtual Foundry, and here with me is Brad Woods, founder, lead developer, inventor, and CEO of the Virtual Foundry. He has many hats. Now, Brad, as you know, my husband is the high school basketball announcer for a local cable station. And he always gives a weather report at the beginning of every one of his broadcasts. So I'm taking a page from his book and letting everyone know that the time today now is 10:35 a.m. Central Standard Time. It is 50 degrees Fahrenheit outside. Now that's 10 degrees Celsius for everyone outside the US. And we've got beautiful sunny skies today here in southern Wisconsin. Now, Brad, today we're talking about democratization. What even is that? We've been talking about democratization since you started this project and founded the company. It's not necessarily a word that rolls off the tongue. It doesn't necessarily conjure a clear image, but I know that it has a lot of meaning for you. And if I have the story right, when you discovered that you could marry metallurgy with FFF 3D printing, this democratization is the vision that you had in mind. So tell me what democratization means to you.
Right. When I first got involved with 3D printing, the first thing I did, and the first thing everyone does, is figure out how to get it to work and make a part. Once I did that, that process alone, and this is in the early days of 3D printing, but that process alone probably took me about 3 weeks. Once I finally, after 3 weeks of effort, succeeded at creating a part, just the plastic simply seemed inadequate. It became clear, or that's what started my mission to develop new materials for this style of 3D printing. And the reason, or why I kind of spotted the connection, is I had actually been working for several years. The Virtual Foundry predates this project by about 15 years. Prior to 3D printing, I had been using methods such as electroforming, electroplating, different techniques of creating metal objects that didn't require a foundry. And one of the techniques that I was developing was working with powdered metals. And there's quite a bit of research on this, and there's a fair amount of hobbyist involvement in precious metal clays, things like that. So the strategy is essentially a combination of precious metal clays and metal injection molding and various forms of powder forming. So the concept of democratizing it is, and this is sort of my general philosophy, I'll pontificate slightly, so bear with. But we've seen since the beginning of the Industrial Revolution, literally the last 150 years, we've seen the development and creation of consumer goods moving from a distributed nature in towns where they had blacksmiths and things like that, where it all became consolidated into large factories. And this continued until recently. And in the last decade, we're starting to see a shift. We're starting to see a trend where people are making more things at home. People are creating things in a more distributed nature. The general term that's become accepted is the maker movement. And this only accounts for part of it. There's a lot more to it than just the people making things at home. But my thought was that if people can make if you can fabricate a 3D metal object at home, it kind of changes just about everything about manufacturing. It opens all kinds of new doors. It lets people create hard goods without casting, without a foundry, without heat, without the risk, the danger, and the complexity. So that was the goal of this project, is just to make it simpler for people to create objects at home.
So what sort of future do you see with distributed manufacturing, this idea that everyone can make their own things at home.
Right. This is the way things are working out now. The focus isn't so much on making things at home, but it's making it so that groups in schools, like STEM programs and fab labs, people like that, can create very sophisticated, very very complex parts that were previously, there was simply no way for them to manufacture them on a low budget or in any way that a small school could afford. So it's one of the sort of the side effects of the democratization has been um, putting these skills to students at a much earlier stage in the school process. So we're past where, I mean, even as recently as, well, 2 years ago, the least costly method of additively manufacturing or 3D printing a piece of metal required a piece of equipment that would cost about $750,000. And that's simply not going to happen anywhere except for the very highest end education, high end higher education. That's the only place it could be. But with democratizing, we've been able to bring the cost down and make all of these concepts available to a much, much wider range of potential users.
One of the great benefits that I see in this idea, this philosophy of democratization, of spreading the manufacturing ability amongst more people, is that we're getting more innovation at more levels. So we've got so many more people throwing their hats into the ring of ideas that make our lives better. And when we're talking about the Virtual Foundry system being affordable enough for even a school, a middle school or high school, to install a complete metal additive manufacturing system, then we're getting ideas of the next generation of engineers. And we're helping those kids just get started on a path to ideas and inventions, and making it easier for people to bring their ideas into reality.
Exactly. And there's a huge swath of people that just haven't had the opportunity, very skilled, very intelligent young people that didn't have an opportunity to participate in these kind of things because they're generally so costly. It like I said, for so long we've moved towards a centralized strategy of manufacturing, and not just manufacturing, but also the ideas and the dissemination of the ideas. They all came from the top down. I believe we're in a phase now where that's shifting. We're moving away from the centralized nature of the knowledge distribution and moving it out to people and making it more accessible.
Now, one thing that we've talked about around here is the idea that there are lots of different technologies for making metal parts out there, and they all have their place. So, casting isn't going away. Machining isn't going away. Metal injection molding isn't going away with the advent of the ability to 3D print metal or to additively manufacture any item. Those traditional manufacturing methods are here to stay. We still need those. The large volume production isn't being replaced by 3D printing, at least today. That may change in the future. But for now, there's a room for all the technologies. So 3D printing and this method ends up being an additional technology. Talk about the impact that having a new way to make things, talk about the impact that has on old problems and old ways of doing things.
One thing we're starting to see is that there are many classes of materials that are extremely difficult to fabricate. Hard materials that are are nearly impossible to machine, and complex shapes and mixtures of different materials that you simply couldn't get in a casting type strategy or a machining type strategy. So none of the things that we're doing, I don't expect them to replace traditional manufacturing techniques anytime soon. but it opens doors and creates new methods of fabrication that simply weren't done before. And a key example is one of the companies that we work with. There's a class of cooling devices called thermoelectric cooling. It's a Peltier device, it's called. And essentially it's just two different types of metal. And when you run electricity through them in one direction, they get cold. You run electricity through them in the other direction, they get warm. What we've done is we've created materials that let manufacturers print those directly onto circuit boards. So you can have heat management systems integrated with the circuit board.
Wow, great. So something that just wasn't possible before.
Right. There was absolutely no way that that could be done in a traditional way.
All right, great. So it's easy to see how democratization applies to this technology and how this technology and others like it are allowing more people to do more things, solve old problems, solve what we thought were unsolvable problems. And just the system that we offer makes this process accessible to so many more people because it's at a price point that is not prohibitive.
Correct. And we expect that as more people participate, we'll find more and more applications, and we'll solve more and more problems that we were never able to solve before. We've had no major change in manufacturing technology in 125 years. Things are milled, they're lathed, they're cast, or they're forged. So really, this is the first time we've added a method of fabrication to the tool set in, over a century.
Well, the creativity of the 3D printing community has just been amazing to me. I love being a part of this industry and seeing all of the things that people are creating and coming up with. It's been amazing.
Yeah, we're seeing people come out of their basements solving problems that, the world's top scientists haven't exactly been able to solve, partly because they haven't focused on it because they didn't think there was a way to solve it.
Vis-a-vis Bradley Woods in his basement in Stoughton, Wisconsin. So Brad, I have one more very important question for you as we wrap up this episode. Why was Cinderella bad at sports?
Hey, something with slippers?
No, she was bad at sports because she kept running away from the ball.
Nice.
So, as you know, next week is Thanksgiving, which is a major holiday in America. It's a time when we pause and give thanks for all the blessings in our lives. And I'm thankful to be working with you here at the Virtual Foundry, Brad.
I feel the same way. Thank you, Tricia.
Well, that's it for this episode. Get out there and make something, everybody, and we'll see you next time.